Well, it's a week on from my last little atmospheric chemistry video, and I'm up on the roof of the new building. This is a spectrometer. Well, this feeds light into a spectrometer. So again, the sort of work I do, all that blue piping and all this plumbing on the back is and comes down to a tap here and a valve on the tap that I can control. This collects light from the sun, but it's measuring in a different part of the spectrum to the instrument I was talking about, the Fourier transform infrared spectrometer. This one uses the ultraviolet and visible part of the spectrum, and we have optical fibres coming off the back of these. Of course, well, we're not getting any measurement at the moment because we've got cloud, but it's just sitting here running itself. So each of these has an optical fibre running down, and we have, this is a new roof setup. So this building went up, we only moved into it less than a year ago, and so these feed down into these pipes which go down into the laboratory, which is much nicer than what we had before. So we have 4 light pipes, one on each corner, that go down for putting a spectrometer on. We'll be putting a sun tracker. The sun tracker is going onto this end here, and we have all these pipes, and then we have these effectively cupboards on the roof. So I should close this lid, but this is a box I built 5 years ago or something. It's got a little relay over here, this one here, which is I can log on to, and it's programmable, so it's just doing its thing, and power supply, a couple of relays, and if I pushed this button, it blows air onto the optics via these little copper lines, and if I push the other button, it'd squirt water through these. So a system like this was running down in Tasmania for about 15 years or something, and finally the computing power was available to work up the entire data set, and it turned out that what it was measuring, which is called aerosol optical depth, it's the amount of aerosol in the atmosphere, sort of, looked like there was more of it every weekend. And it turns out that Monday to Friday, people on this station were going out and washing these windows on the front of these, and they didn't go out to the site on Saturday and Sunday, so it would build up over the weekend a layer of salt because it's exposed to the ocean breezes, and so on Monday to be cleaned, so he had to throw away more or less the data for weekends for 15 years of measurements. So this is my solution to the problem. We have compressed air comes out of these, we have water comes out of these. So the water is connected here on this tap, and this valve here is triggered by that relay, and it just pulses water onto here, which dissolves the salt from the ocean, like salt just being deposited is the word I'm looking for, onto it. And then these all give a pulse of air and blow off the droplets, so it dries without droplets on it. Now there's a little bit of rain around, so we've got a few droplets on here, but this just sits here and runs. sort of things. This was all put in, it was looking like it was really good material for this bench, but if you put something like this narrow base with a quite heavy load on it onto here and you push that, it was able to shake backwards and forwards across this way. So I've got these aluminium angles and bolted them on underneath and put these all the way across, and so now this is nice and stable. So I've firmed that up, and yeah, this is all a bit messy at the moment, but yeah, this is a control box for the washer, and so we've got cables can go into here and go up to the top or down to the lab, and we've got a lot of power and Ethernet available here. These are a couple of control boxes for the sun tracker, and then here's the weather station we have on this roof, and this is the same weather station except it's a later model, and you see they've got all these little spikes around here, and that is to stop the birds from pooing in the tipping bucket in the funnel. And we're working on inlets here. We have an air inlet comes here, so we've made this mast can pivot down at this point here, and so we have an inlet line comes down through underneath the mesh here up into this box which I had built by the workshop, and it comes in and into this tube here, and that goes down into the laboratory, and we have yeah, so all of this is set up. We got to design it alongside the architects. There's an F-face here that allows us to put more air lines down. So I designed this to take 4 inlets, and we actually had a tragedy with an instrument down in the lab that's got core flute taped to it. There's a mesh in underneath the bottom of there that you can't see, and water was dribbling around, and this was pulling air quite quickly into the instrument below, and it rained, torrential rain for days. Actually, you can see here's another one of those inlets without, it's not being used, and so that's just ready for another one. And you see there's a, I don't know if you can see with the light we've got, but there's a mesh on the bottom. The water ran round and wicked around the bottom of here, and then got sucked up into the airline, and then filled the entire line, and ended up in an instrument downstairs and doing about maybe $5,000 worth of damage. So we weren't too pleased with that. I don't know where the spiders are getting in here, all these cobwebs up here. Anyway, so one of the reasons why we wanted to move onto this platform is this. So if you remember on the previous one with the FTIR and the sun tracker, there was a lot of trees and we couldn't see the ocean. We couldn't even see this building that I'm standing on now. The atmosphere is about 30 times thicker when you look through it, when you look at the horizon, because you're looking at an angle through the atmosphere. Whereas the sun's directly overhead, it's about 30 times less atmosphere. So if you're looking for a gas, trying to measure a gas that there's not much of in the atmosphere, it's a low concentration, you want to look at it when you have the longest path of absorption through the atmosphere. And so over on the other platform we don't get to see the sun until it's maybe 20 degrees, 25 degrees above the horizon. So there are some measurements we just can't make from that platform. Whereas with this one, we've got this so we can get, for nearly the entire year, we can get the sunrise. And so these platforms are designed so that we can see over this barrier, the wall. So we've got that view to the east, and to the west we have this great lump of rock, and the sun will set behind that a lot of the times, so we can't see the western horizon, but it's not too bad, and it's also better than actually you can see that building over there behind the trees. It's the one I was standing on before. So, another sort of things I do, I've just bought these set of cameras. They're only temporarily installed. I need to get onto them because we're getting sun damage to this plug already. But they're just so we can see what's going on the roof and in the laboratory from over in the other building. And we'll just close this couple of doors. So this instrument here is one we built in-house. I'll just close this as well. It took 3 goes to get these doors right. When we first came and looked at them, they just had, same as this, without this step, but this board on, and you would have had to unscrew it to get access to it. And it took, and also all the power points and internet ports, Ethernet ports were on the outside, on this side, instead of inside, so it was entertaining. But yes, they're quite good now. This unit here is effectively a telescope. There's optics down underneath here, and this can rotate, and this is designed to look at the reflected light from the sun in the atmosphere at different heights, and it just sits and ticks like that when it's running, and it takes a measurement at the different angles, and from that you can derive information about, I think, aerosols from this. It's called a max-DOAS, multiple axis optical absorption spectrometer, max-DOAS. Oh, I think that's right. I helped with the building of this and have written software to talk to it, but I am not so experienced with it. I wrote a software package that runs the measurement of this. It runs a spectrometer. It doesn't control the sun tracker. It just checks. So it's running now, but because we've got low intensity from the sun, it won't be actually collecting measurements. So this platform here, the new sun tracker I'm building, will go onto this end here. So I'll put a plate over this end of here as a see, look at that. That's why I had to beef up the setup over there, because of that. But I'll put an aluminium plate over here, and there's another plate goes on top, and then the sun tracker goes onto that, and then I'll have to make something to go from there to waterproof it. Oh, look at a bee up here. There you go. And then that light will go down into the new spectrometer. In the meantime, I've just got, this is just temporarily, this camera's stuck here and that one's there. I'll make up some masts to go onto this handrail to mount camera one maybe over in that corner and one over this corner, so we'll be able to get a good view of the platform from either side. And yes, this is all very nice, new. I mean, compare this to the size of the platform that I was on last video, and you'll see this is pretty amazing. So I'll go down into the lab downstairs and show you that. This is the laboratory below that platform. So the pipes that we were looking at are these. 4 are the optical pipes, and there's 2 on the other side up there. And these, as you can see, are where we're getting cables coming down. We've got all this cable racking put in, and with power and Ethernet on them, so that we can run all our cables. And then after all of that, one of the first jobs I had to do in this lab is put this cable across this wire, or chain, across here to run cables from this end bench across to this. So even with all the thinking you do, you miss the odd thing. But the air line that I was referring to before is coming down here and running all the way across, and at the moment it's running to this instrument. So this is a low resolution spectrometer, one of the ones that we designed these ourselves. So this is one that we built in-house, but it's the one that got water sucked into it. So this is another one. We've commercialised these, and they got called a Spectronus, which I think sounds like a spell from Harry Potter, but the marketing people at Ecotech thought Spectronus was a good name for it. So we've got a set suite of gases here that we use for flushing the instrument or calibrating it. And this is a low resolution, actually tucked away in the back, up on this end. There's a, hard to see it, but there's actually a, without the reflections, but there's a spectrometer in behind here. You can actually see the bottom of the spectrometer there. And there's a glass cell here, and light, infrared light, is bounced backwards and forwards inside of that. In fact, here is a diagram of the cell, and light is, infrared light is put out, bounces back and forward between mirrors, and there's a detector that the light comes back onto, and the gas is flushed through this cell, and the light is absorbed by the gas in the cell, and from that we get a measurement of the various species. So we've just updated the computer on this one. So that's another thing I do. I put the operating system onto that. This is an old computer that we just replaced. We're just hanging on to. Oh, and this is the computer running the measurements. So this is the software that I wrote here. This is just logging, this stuff here is just logging temperature and humidity, and this software here is running the large maximised thing, is running the sun tracker, and this is collecting spectra, but it won't be saving them because there's low signal. So that's the spectrum, and this is the intensity. If this is a nice day, you get a beautiful curve that just rolls over there, but you can see it's very low intensity, and we've had a lot of times where we're not even really seeing the sun because of the cloud. And the spectrometer is actually inside of this box and is temperature controlled, There's a bit of a temperature control unit on the end of it. Again, this is built in-house. And there's another unit, same sort of deal. So, and down here is a cardboard cutout that I made of the high resolution spectrometer that we should take delivery of soon. And so we've worked out where we're going to put it, and the light will come down. This is where the light will go in, just here, and it'll come out of that over there. And so there'll be a sun tracker putting beam of light down into this. So here's the sun tracker I had over in the other lab on the last video, and I've just set up a camera to look at it so that I can start this up and have it run, and we can just keep an eye on it and see if it's running reliably, which it wasn't when it was in Darwin, and try to debug it. So there's a background job, and here's the view from our lab, which is the envy of a lot of people. It's not too bad at all, I think. So anyway, that's our new, oh yeah, I've set up a bit of a workbench down here. We've even got an extraction fan for our soldering, and I've got my little soldering station and bought a tool kit and so forth. So it's kind of fun to go and spend other people's money. Anyway, that's the new lab.